Hello and welcome to our 9 a.m. press conference, Arctic Report Card 2015. Our speakers will be Rick Spinrad, Noaa Chief Scientist, Martin Jeffries, Arctic Science Advisor and Program Officer for Arctic and Global Prediction at the U.S. Office of Naval Research, Jackie Richter-Menge, Research Civil Engineer at the U.S. Army Corps of Engineers Cold Regions Research and Engineering Laboratory, and Kit Kovacs, Biodiversity Research Program Manager at the Norwegian Polar Institute. There are press releases on the back table, and someone from Noaa Public Affairs is over there if you need anything after the press conference. Thank you.
Thank you, and good morning. Appreciate your joining us this morning. My name is Rick Spinrad. I'm the Chief Scientist for the National Oceanic and Atmospheric Administration, NOAA. I am pleased to join this distinguished panel in announcing the findings of the 2015 Arctic Report Card. For 10 years, this report has been a key resource in understanding Arctic change and is a shining example of international scientific collaboration at its finest. Warming is happening more than twice as fast in the Arctic than anywhere else in the world. We know this is due to climate change, and its impacts are creating major challenges for Arctic communities who depend on the region for sustenance and cultural identity. We also know what happens in the Arctic doesn't stay in the Arctic. Changes in the region affect climate globally and security internationally. The United States is increasingly making the Arctic a focus of national attention. We saw this just last August when President Obama traveled to Alaska to draw attention to how climate change is affecting the Arctic in dramatic and subtle ways. Also this year, the U.S. took over the two-year chairmanship of the Arctic Council and is working with other nations to advance safety, security, and stewardship in the region. In the past 2 years alone, NOAA has made an annual investment of nearly $15 million to collect the critical environmental intelligence that provides citizens, policymakers, and industries the information they need to make important decisions and stay resilient in the face of great change. NOAA's science priorities in the Arctic are threefold. First, improve weather and sea ice observations, forecasts, and warnings for communities along the coastline and beyond. Second, improve understanding of climate impacts on biological resources, human health, and natural habitats, with a particular focus on monitoring changes in our nation's economically valuable fisheries in Alaska that have ramifications elsewhere. And third, improve navigational services that transportation, energy, and other industries need to stay safe on the seas and keep commerce flowing. The United States is an Arctic nation, and what happens in the Arctic matters to all of us from strategic, climate, and national security perspectives. As you'll see today, one could argue that the trailing indicators of the Arctic are in fact the leading indicators for the rest of the planet. Shortly, I will turn to Dr. Martin Jeffries, Arctic Science Advisor for the Office of Naval Research, who will provide you with an overview of this year's Arctic Science Report Card. Also joining Martin and elaborating on the report findings, as you've heard, is Dr. Jackie Richter-Menge, Senior Research Scientist with the U.S. Army Corps of Engineers Cold Region Research and Engineering Lab. And we're also pleased to have with us Dr. Kit Kovacs, Biodiversity Research Program Leader with the Norwegian Polar Institute, who will discuss how Arctic wildlife, such as the walrus, are responding to warming. Martin?
Thank you very much, Rick. Good morning, everybody. I'm Martin Jeffries. I'm Principal Editor of the Arctic Report Card, and I'm pleased to add my welcome today to the official release of the 2015 update to Arctic Report Card. This is the 9th annual update of the report card, which was first published in 2006 as the State of the Arctic Report. This year's report is the work of a large international team of authors. 72 authors from 11 different countries contributed to a dozen essays. All the essays in the report card were subject to independent peer review that was managed by the Arctic Monitoring and Assessment Program, or AMAP, of the Arctic Council, and we thank AMAP for conducting this external independent review. The report card is published online, where key highlights from the essays and a video that summarizes the highlights of the report card can be seen on the front page of the website, which is now live. We'll now present some highlights of Arctic Report Card 2015, and first I'd ask Jackie to tell us about the atmosphere.
Okay, thank you, Martin. Since the beginning of the 20th century, Arctic-wide annual average surface air temperatures over land north of 60 degrees north has increased 2.9 degrees centigrade or 5.2 degrees Fahrenheit. As Rick has already mentioned, this is more than twice the warming observed elsewhere on Earth. Between October 2014 and September 2015, the Arctic-wide annual average surface air temperature over the region was 1.3 degrees centigrade or 2.3 degrees Fahrenheit above the 1981 to 2010 baseline average. This is the highest value in the observational record beginning in 1900. In general, air temperatures in all seasons were above average throughout the Arctic, with extensive regions exceeding over 3 degrees centigrade or 5.4 degrees Fahrenheit above the 1981 to 2010 baseline. It was also another interesting year for sea ice, which is clearly affected by this persistent warming trend in surface air temperature. In February 2015, the lowest ever maximum ice extent in the satellite record, which begins in 1979, occurred on the 25th of February. This was 15 days earlier than average. In February and March, the oldest ice, defined as being greater than 4 years old, made up 3% of the ice cover, while new first-year ice made up 70% of the ice pack. 30 years ago, in 1985, the composition of the ice cover was much different. 20% of the ice pack was over 4 years old, and only 35% was classified as first-year ice. In September 2015, the minimum sea ice extent was the fourth lowest value in the satellite record. These observations collectively confirm a trend towards a thinner and more vulnerable Arctic sea ice cover. Now, Kit is going to talk to us about the impact of this declining sea ice cover on the Arctic marine ecosystem.
Thanks, Jackie. Sea ice decline is believed to be the most pervasive threat to ice-associated marine mammals, including walruses. In the Pacific Arctic, vast walrus herds are now hauling out on land rather than on the sea ice, following the northward retreat of the pack ice edge to a position over the deep Arctic Ocean. This new haul-out behavior is raising concerns about the well-being of females and their young that must now make 180-kilometer-long, that is 110 miles, feeding trips each direction from coastal haul-outs to areas of high prey abundance, rather than simply utilizing nearby ice edges as they did in the past. Walrus populations in some areas are also still being heavily impacted negatively by hunting. In the case of Svalbard, in the Atlantic Arctic, where I do most of my work, a hunting ban since 1952 has allowed the walrus populations to recover, even though ocean air temperatures have increased and sea ice has markedly declined. The temperature of surface waters of the ocean are increasing as sea ice retreats in summer and previously ice-covered water is exposed to solar radiation. Sea surface temperatures, or SSTs, and upper ocean temperatures are increasing throughout much of the Arctic Ocean and the adjacent seas. In 2015, SST was up to 4 degrees Celsius higher than the 1982 to 2010 baseline in eastern Baffin Bay and the Kara Sea north of central Eurasia. The Chukchi Sea, northwest of Alaska, and Baffin Bay, west of Greenland, have the largest warming trends at more than half a degree C per decade since 1982. Increasing ocean primary production, that is, the conversion of CO2 to biological material, is also being observed as summer sea ice extent declines. In 2015, widespread, above-average primary productivity was observed throughout the Arctic Ocean and the adjacent ice-affected seas, particularly in the Barents Sea, north of Norway, and in western Russia, where primary productivity was 21% above the 2003 to 2015 baseline. The Barents Sea also has the steepest primary productivity trend at 30% per decade over the period of observation, and that is from 2003 to 2015. Fish populations are also clearly changing. For instance, in the Barents Sea, boreal, that is warm water affinity species, are moving north and displacing Arctic cold water affinity species. Most of the fish species moving into the northern Barents Sea are large boreal fish predators, such as cod, beaked redfish, and long rough dab. This is likely related to improved habitat conditions for them, both in terms of warmer water and greater food availability in the northern Barents Sea. Over to you, Martin, for the terrestrial system.
Thank you, Kurt. So, on land, the tundra has become less green than it was. Satellite observations since 1982 of peak tundra greenness, a measure of vegetation productivity and a proxy that's strongly correlated with above-ground biomass, show a consistent decline, or a browning, since 2011. Also on land, snow cover extent in April 2015 was above average, but in May and June, snow cover extent on land was below average. This continues a consistent pattern of early spring snowmelt during the past decade. In 2015, June snow cover extent in both the North American Arctic and the Eurasian Arctic was the second lowest in the satellite record, which dates back to 1967 for snow cover. Continuing the land theme, Arctic river discharge is increasing. In 2014, the year for which we have the most recent complete record, the combined discharge of the 8 largest Arctic rivers was 10% greater than the average of 1980 through 1989. Since 1976, discharge of the Eurasian and North American rivers has increased at a rate of 3.1% and 2.6% per decade, respectively. Ice on land, as represented by the Greenland ice sheet in this year's report card, experienced extensive melting once again in 2015. Melting occurred over more than 50% of the ice sheet for the first time since 2012, when we had the exceptional melting of around 90% of the ice sheet affected by surface melting. Also in 2015, melt season duration was as much as 30 to 40 days longer than average in western, northwestern, and northeastern Greenland, while elsewhere on the ice sheet, in the more southerly regions, melt season duration was at and below the average. This unusual pattern of melt season duration is consistent with anomalous or exceptional jet stream behavior that caused persistent clear sky conditions and enhanced melting in the northern regions of the ice sheet, but also promoted cold northerly airflow and suppressed melting over the southern regions of the ice sheet. These strong connections between the Arctic and the mid-latitudes, as exemplified by that cold northerly airflow over the southern part of the Greenland ice sheet in the summer of 2015, these kinds of Arctic to lower latitude connections also occurred earlier in the year elsewhere. So, for example, during February through April 2015, there was persistent northwesterly airflow over North America that caused anomalously cool conditions in northeastern North America. In contrast, on the opposite side of the continent, between November 2014 and June of 2015, there were anomalously warm conditions in the Pacific Arctic region due to warm southerly airflow into and across Alaska. As an example of consequences of such warm southerly airflow, during May and June of 2015, warm, dry conditions occurred in the central Alaska that contributed to the second worst fire season on record for those months in that region. So, those are some of the highlights of Arctic Report Card 2015. Kit will provide a brief summary of the state of the Arctic environmental system.
Thanks kindly. The impacts of the persistent warming trend of over 30 years are clearly evident in land and in ocean environments. And these impacts are influencing Arctic marine and terrestrial ecosystems. Given consistent projections of continued warming temperatures, we can expect to see continued widespread and sustained change throughout the Arctic environmental system.
Thanks, Kit. Now, before we close, we'd like to acknowledge the work of a number of people who are vital to the success of the Arctic Report Card. First, the authors, many of which are here today. These authors generously volunteer their time and expertise in preparing the essays. Second, the editorial advisory board, of which Kit's a member, which helps us identify essay topics and authors and assists with the internal review. Third, certainly a shout out goes to Nancy Saraidi and Tracy Nakamura, who prepared the report card's website hosted by the NOAA Pacific Marine Environmental Laboratory in Seattle. Fourth, our thanks to Dr. Kathy Crane, who recently retired after 14 years of service with the NOAA Arctic Research Office. Kathy has been a strong supporter of the Arctic Report Card and a tireless promoter of international collaboration in Arctic sciences.
And last but not least, I'd like to thank my co-editors of Arctic Report Card 2015, Jackie here of the Cold Regions Research and Engineering Laboratory in Hanover, New Hampshire, and down here in the front row, Dr. Jim Overland of the NOAA Pacific Marine Environmental Lab. This is the editorial team, and I'd just like to add my thanks to the authors who, there wouldn't be an Arctic Report Card without them. So that concludes the 2015 update to the Arctic Report Card. I thank you for your attention and will now open this session to questions.
Thanks. Any reporters in the room who have any questions, please raise your hand and please state your name and affiliation. Thank you.
Hi, I'm Rose Pidcock from Carbon Brief. So over the weekend, the world signed a historic deal to tackle climate change and curb emissions. And one of the things in that deal was reaffirming the ambition to limit global temperature rise to 2 degrees, perhaps even pursuing efforts towards 1.5 degrees. From an Arctic perspective and the impacts that we're already seeing and the impacts that are projected, can you just say how significant you think that is, that warming doesn't surpass the 2 degree mark?
Yeah, I think from a policy perspective, obviously there are a lot of considerations with respect to the thresholds, if you will, and I think the scientific evidence is pretty conclusive with respect to the range of potential impacts associated with that threshold. So clearly the good news that comes out of COP21 is a recognition, if you will, among the 190 or so member states that those thresholds have significant consequences with respect to societies, economies, and the ecosystems. So what you're hearing here today with the Arctic Report Card is clearly an indicator that absent the appropriate monitoring and observational networks, we will not have the capability to determine how well we are meeting those kinds of thresholds. So I think the main point of relevance at the intersection of the report card and COP21 is the value associated with observational networks and the ability to verify policy goals as expressed in COP21.
If I could add that COP21 calls for a global average 2 degrees Celsius maximum increase in temperature. We already know that the Earth is warming not uniformly warming, but in some places, such as the Arctic, it's warming much more quickly than elsewhere, and we could expect that to continue because of the persistence of greenhouse gases in the atmosphere. And I wonder if Jim Overland, you would care to say anything about projections for Arctic warming based on models which include greenhouse gas concentrations.
Yeah, if we think of a limit of 2 degrees Celsius as for the globe, that would still mean a 4 to 5 degree temperature increase in the winter months for the Arctic. That's based on models, but the importance of the report card is almost every year we see new surprises on the rapidity of the types of changes that we're seeing. And so the real world with the data in the report card is the real information that things are rapidly evolving.
Thanks, Jim.
Yeah, hi, Jonathan Amos, BBC. On the topic of the walruses, you're probably aware there's some pushback from the skeptic community on this topic, pointing to mass haul-outs back in the 1970s. I wonder if you'd address that for us. You know, their suggestion being that this is more a function of a very large population now in walrus numbers. But also, is there any evidence of a change in benthic species as well? Because walruses obviously depend on feeding at the bottom, and I wonder if the temperature changes in the Arctic Ocean are affecting that aspect.
Yeah, there's a whole bunch of things to line up there. One being that the walrus population in the North Pacific is thought to have dropped by over 50% in the last decade. So the large numbers situation is clearly not driving these land-based haul-outs. Luckily, for a research perspective, a fair number of animals were wearing small tags, location tags, in the particular year that we had the sea ice drop off the shelf and go into the deep Arctic Ocean. And females shifted their haul-out patterns dramatically and almost immediately at that time to hauling out on land. The land herds that we're seeing in the Pacific have not been seen before in the numbers that are occurring. Clearly, walruses have traditionally hauled out at some of those locations a very long time ago, based on Aboriginal information about where they used to harvest. But it isn't in the lifetime of living people that those things have happened, and they're happening now. Benthic communities have been quite well studied in the Bering Sea. A wonderful series of papers, including papers in Science by Jackie Grebmeyer and her colleagues, clearly demonstrate declines in benthic infauna. So I don't think there is much uncertainty here. We have a dramatic situation in the North Pacific and a dramatic shift in walrus ecology in that area.
Thank you, Kit.
Are there any other questions in the room?
George Drake from the Tahoe Mountain News. You mentioned the walrus birth rate too, if I understood correctly. Did you say that it was up despite the population being down?
I did not. I didn't mention walrus birth rates. There have been changes in reproductive parameters for sure. And part of that big decline was thought to have been that walruses were near carrying capacity in the North Pacific. So we saw shifts in reproductive parameters, increased time to sexual maturity, decreased reproductive rates by females that started that decline. The decline has been exacerbated by changes in sea ice and changes in benthic infauna. So there are reproductive parameters certainly playing a role there, and those seem to be showing slight signs of increase or at least relaxing and coming back to a more stable situation since around 2000. So we expect that that walrus population, all other things remaining equal, will stabilize at this new level. So reproductive parameters are certainly part of the issue here and a complexity in interpreting the situation. But carrying capacity of walruses in the North Pacific and elsewhere is clearly declining.
I think we have a couple questions on the chat. Zoe?
Yes, the first one is from Malcolm Ritter of the Associated Press. Regarding the record average annual air temperature over land, that number is expressed only in relation to the long-term average. What is the absolute value of that record temperature?
Jim, do you know that value offhand?
I'm not sure what you mean by absolute.
What's the actual value
Oh, the actual.
rather than an anomaly as expressed in the report card?
Yeah, sorry, I don't have that on my at my fingertips. I can look it up though and provide it.
Okay, thank you.
Zoe, is there another question?
I think it's around 10 degrees, but I have to. I'll look it up.
Follow up.
Thank you. The second question I have is from Catherine Bagley of Inside Climate News. Will this year's record El Nino have any impact on the Arctic system?
Jim?
Good question. Not only do we have an El Nino, but we've also had a warm Pacific in the last couple years that added to the California drought. So, as was mentioned this year, for the first time in 15 years, we've had these strong southerly winds. And if we look at past El Ninos, they have had an Arctic impact and a warming over Alaska. But if the winds are particularly strong, that connection can be weak. So the answer is there's a possibility, but not a certainty.
If I can make one quick addition, in recognizing the magnitude of this year's El Nino within NOAA and our operational activities, we have redirected some of our ships and aircraft to conduct additional observations in the central North Pacific to try to address exactly the issue that Jim just alluded to.
I think we have a question in the room.
Ned Roselle, Alaska Science Forum. I just wonder if you could explain why the tundra would be less green.
Fortunately, we have in the audience Dr. Howie Epstein of the University of Virginia and Dr. Uma Bhatt of the University of Alaska Fairbanks, two of the authors of that particular essay on tundra greenness. Would you like to comment on that question?
Sure. Well, thanks for the question. It's an excellent question. And we don't have the answer to the question yet. So when you're looking at a long-term record like vegetation greenness, if we see a drop in the greenness for any given year, it's not something that would raise much attention. And if we see a drop in the greenness for 2 years in a row, that may not raise much attention either. We see these kinds of things throughout the satellite record that goes back to the early 80s. In this case, this drop has gone on a little bit longer than that. We're looking at, depending on where in the Arctic, a 2 to 4 year consistent drop in the vegetation. And so it's something that's actually just gotten on our radar from a terrestrial ecology perspective. And so we don't really have the answer, and it can be a variety of different things. One idea is that changes in snow could have dramatic effects on the vegetation. It could be atmospheric conditions, it could be changes in cloudiness, it could be aerosols, it could be other things, it could be disturbances on the landscape. So I would guess that this is going to be an interesting line of research that we'll probably see in the near future. Yeah, again, I'm Howie Epstein, and I'm with the University of Virginia.
Thanks, Howie.
Were there any questions in the room? Okay.
I'm Julia Rosen. I'm a freelancer. I talked to some people yesterday about this greening issue, that maybe it has implications for permafrost stability. Can you talk a little bit about why it would matter if the vegetation changes?
Once he gets some mic.
Yes, this is from Emily Gertz from Participant Media. To arrest or reverse Arctic change, what would the maximum allowable temperature increase be?
Should I answer? Do you want me to answer now? Okay. So the question was effects of vegetation change on permafrost. Is that right? Yeah. So one thing that seems to be particularly clear is that if you increase the vegetation on the landscape, this tends to have a protective effect on the permafrost. Increasing the vegetation on the landscape will do a couple of things. It will increase. It provides insulation to whatever's below the vegetation. So it will tend to increase the winter ground or soil temperatures. And it will tend to decrease the summer ground or soil temperatures. Summer is when we experience the thaw, and so often what happens is if you increase vegetation, you will decrease the summer soil temperatures, and you might decrease the depth of the active layer, which is the layer that thaws every year. There are other things, though. There are effects of vegetation on snow cover. Vegetation tends to trap windblown snow, and that can also provide an insulating effect for winter soils. The vegetation will also change the reflectivity of the land surface. So if we increase shrubby vegetation, which we see in a lot of areas, the shrubs tend to stick up above the snowpack. So during the spring, you would get a much less reflective surface than you do when you have snow. And so this is called the albedo, the reflectivity of the incoming solar radiation. And so you will get a decrease in the albedo, which will lead to more heating of the surface, which could lead to more heating of the air. So there could be a positive effect of increasing vegetation on increasing air temperatures. So there are multiple effects that could influence permafrost.
Thanks, Howie. Could the other question be repeated?
Yes, sure. So from Emily Gertz of Participant Media, to arrest or reverse Arctic change, what would the maximum allowable temperature increase be?
I'm going to put Jim on the spot again.
Unfortunately, we passed some critical points on that. If the globe goes to 2-degree warming, we're looking at a 4 or 5 degree warming in the winter for the Arctic by 2040. 2050. That's based upon the CO2 that we've already put into the atmosphere and will be putting in for the next 20 years. So we call out to 2040 or 2050, we're already in the adaptation mode. We're going to have to deal with those types of increases for the residents and ecological impact for that type. If we do go with a reasonable mitigation scenario, that will slow down and have a big effect in the second half of the century. So it's very important that we proceed that. So the next generation may see an ice-free summer, but hopefully their descendants will see a return of more sea ice later in the century. The one good news is in 2007, the report card noted the absolute minimum sea ice extent that we've seen, and we were very concerned back then about a tipping point, that you lose the sea ice, it opens the water area, it absorbs more heat, you have less ice, and so on. That doesn't seem to be the picture, the large picture. There's a fairly close association between air temperature value and the amount of sea ice we see. So if we stabilize temperature or reduce temperature globally, that will also looks like it will stabilize the Arctic climate as well.
Thank you, Jim.
Are there any other questions from reporters in the room? Okay.
Do you have any comment on the Greenland ice sheet?
Sorry, was the question, do we have any comment on the Greenland ice sheet?
Yeah, what's the current status of it?
Sorry, could you repeat the second?
What's the current status?
What's the current status?
Marcus.
So we reported a few minutes ago that in summer 2015, the spatial extent of melting over the surface of the ice sheet exceeded 50% for the first time since 2012, when there was a record extent of melting of around 90%. This year also, the duration of the melt season was 30 to 40 days above average in the northern regions of the ice sheet, but actually at or below average in the southern regions. The ice sheet continues to lose mass, as recorded by the GRACE satellite, which almost quite literally weighs the ice on Greenland. And we see that the albedo, or reflectivity, of the surface of the ice sheet in the summertime, there's still a continuing long-term downward trend in the albedo, or reflectivity. And we also reported in the report card that the so-called marine terminating glaciers, these are the glaciers that flow out of the ice sheet to the ocean, and they actually reach tidewater and in many cases go afloat. Those tidewater glaciers, marine terminating glaciers, they continue to retreat. That's the summary of the Greenland ice sheet section in the Arctic report card this year.
Are there any other questions from reporters in the audience? Are there any other questions on the chat? No? Okay, thank you. That concludes our 9 a.m. press conference on the Arctic report card. Our next press conference is at 11:30, Accidental Geoengineering.